Okay, today we're going to talk about substitution. So you may have already learned how to solve systems of equations, which just means that we have more than one equation by graphing. Usually people learn substitution next, and then a lot of times elimination will be third. So that's the order we're going to go, but obviously you can watch the videos in any order that you want. So with substitution, one of the easy ways about substitution is, especially if one of your two equations already has a variable by itself. In this case, we have a y already by itself, and over here we have an x already by itself. So given that situation, substitution is almost always easier, especially if you don't have maybe graph paper or coordinate plane, or if you don't have the skills or the confidence in the skills that you need to get y by itself, to put it in slope-intercept form, then you can use substitution as an example. So anyway, let's go ahead and see how this works. Just like in a normal equation, if you solved and you got an answer like x equals 5, and you wanted to go and check to make sure that does x equal 5, does that make sense? And you would replace x with 5, and you would see if what you got on the left side equaled the right side. It's the same thing with substitution. That's all you did. You substituted 5 in for x. But now we're going to substitute something a little bit larger than just a number. In our case here, we have y by itself, meaning y equals or is the same as x plus 4. So we have that in line 1. In line 2, we're going to substitute or replace y with x plus 4 because y is equal to x plus 4. So here's what this would look like. We would say 3x plus, instead of y, because y is equal to or is the same as x plus 4, I'm going to say 3x plus x plus 4, and then equals 16. So all I did is I substituted, or I replaced y with x plus 4. And why I did that was because in line 1, that's what I was told, that they were equal to each other. For example, if y is 5, then we know x has to be 1, because 1 plus 4 gives me 5, and so on. Now, when I want to solve, I want to figure out what does x equal. Well, I have to look first for like terms, and I do. I have a 3x plus a 1x. 3x plus 1x is 4x. So I'm going to write 4x plus 4 equals 16. Now, to solve for this, I'm going to just go through my standard process of solving. So I'm going to undo adding 4 by subtracting 4 on both sides. I'm left with 4x equals 12. Finally, to get x by itself, divide both sides by 4. And I'm left with x equals 3. Now, unfortunately, we're not done. So we know what x equals, just like with graphing where we found the coordinate point where they intersected and we wrote the coordinate point, the x comma y, that was our solution. In this case, we need the coordinate point. So if I were going to write this as a coordinate point, right now what I have is the x value. I have that it's 3 comma something, right? Well, I don't know what the something is. I need to figure out what y value makes this true. So you're going to substitute everywhere I have an x with a 3, because we just found that x equals 3. So what is 3 plus 4? Well, that would be 7, meaning that y has to equal 7. So this is actually our solution to that first system of equations. So when x equals 3, y equals 4, if you were to quickly do that here, you would see you'd get the same, or I'm sorry, when x equals 3, y equals 7, you would get the same answer here. If I replace x with 3, 3 times 3 is 9. And when I would subtract 9 from both sides, I would get 16 minus 9, which is 7. So it is true for both equations. Now, number 2, over here in purple, I just wanted you to see that you didn't have to get y by itself to be able to substitute. You could have any variable by itself, even an x. So in our case, what we're going to do now is we're going to replace everywhere I have an x with this entire 25 minus 3y. So instead of 4 times x, I'm going to say 4 times 25 minus 3y. So I'm replacing x with 25 minus 3y because x is the same as this. So instead of 4x, I'm going to write 4 times 25 minus 3y. Now that's just this little part right here. Now we still have the plus 5y over here on the outside, so plus 5y equals 9. Now what do I do next? Anytime we see parentheses, we want to go ahead and distribute. If you want to draw your wall, you can. But I'm going to distribute. I'm going to take this number on the outside and multiply that to each term on the inside of parentheses. 4 times 25 is 100. Why would you pick a problem that had such large numbers? You'll be okay, you have a calculator. 4 times negative 3y would give me a negative 12y. And I still have this plus 5y out here on this side. And then what are we equal to? We're equal to 9. So I haven't done anything there. All I did was distribute the 4 to the 25 minus 3y. Now, after we distribute, we want to look for like terms. I have a negative 12y and a positive 5y. So when I combine those, I still have a positive 100, so 100. Negative 12 plus 5 gives me a negative 7y, and this is equal to 9. 2 steps left. I need to get rid of this 100 to get y by itself. When I move a positive 100 to the other side, I do that by subtracting. So I'm going to subtract 100 from both sides of my equation. So I'm left with a negative 7y, and I'm just dropping down. 9 minus 100 gives me a negative 91. Now again, if you use a calculator, that's fine. You're going to divide both sides by a negative 7. Just be careful with the negatives. A negative divided by a negative is a positive, and 7 goes in there 10 times would be 70, and you need another 21 to get to 91. 7 times 3 is 21, so therefore this would be 13. So y is going to be positive 13. But again, you could just use a calculator. Now that's not our answer though. So remember, our answer is a coordinate point. We're looking, where are these two lines intersecting? So we know they're intersecting at something comma 13. We just have to figure out what that other something is. So I know that part of my answer is something comma 13. I don't know what the x is, but I know y is 13. Now let's figure out what x equals. Let's just take line 1, and we're going to substitute or replace everywhere we have a y with 13. We did that in our head over here because we had lower numbers, and so easier to deal with. 3 plus 4 in our head, not too bad. But dealing with 13, let's go ahead and just write it out so you guys can see. So I'm going to take the information from line 1, and I'm going to replace where I have a y with 13. So instead of x equals 25 minus 3y, I'm going to get x equals 25 minus 3 times 13. Now, 3 times 13 is 39. So I get that x equals 25 minus 39. Now, what is 25 minus 39? Well, that is going to be a negative 14. So x equals negative 14. So if I were to graph these two lines, I would get my x comma y to be negative 14 comma 13. Now, most of our graph paper only goes from negative 10 to positive 10. So this would not have fit on a typical graph paper. So this is another example as to why knowing other methods to solve more than one equation and seeing where they would intersect would be helpful.